Basically, did I discuss the lens? Oh, sorry, not lens. Magnification till now, बच्चों? At least just tell me. Magnification discuss किया अभी हम लोगों ने? Literal linear magnification? No ना, अभी तक नहीं discuss किया. अच्छा ठीक है, कोई बात नहीं. So notes में आपको मैं बता देता हूँ. Basically, what is magnification? Okay, so basically linear, देखो, this is the mirror formula that I have written. And the next is the magnification. So linear magnification, it is the ratio of image distance to the object distance. Image distance by object distance is called a linear magnification. This quantity tells you what is the basically the relationship, whether the image is enlarged, whether the image is of same size, whether the image is small than the object, right? So this ratio tells you about the same, right, everyone? And you have to use the sign convention. If the object distance is in negative, if the object distance is in positive, so you have to use all the positive and negative sign in the equation itself, right, everyone?
Yes.
Okay.
Okay.
Chalo. Okay. Okay. Chalo, that's great. Positive magnification means virtual and erect image. Negative magnification means real and inverted. Only the sign tells you the nature of the image, whether it is virtual erect, whether it's real and inverted. Clear, everyone?
Yes.
Zainab, Aayan, Junaid, Arish. Clear, bacho?
Yes. Yes.
Okay. Okay. Let me tell you this thing. If the value of magnification is less than 1, देखो यहाँ पे हम लोग sign को discuss नहीं कर रहे. Okay? Sign we are just taking the magnitude. Magnitude means just a number. If the magnification is less than 1, so image will be diminished. Right? If the magnification is equals to 1, the image would be of same size. Image जो है object का वो same size होगा. Clear? And if the image is greater, if the magnification is greater than 1, it means that the image would be enlarged. Clear, everyone?
Yes.
Any doubt so far to anybody?
No.
No.
Please tell me, everyone. Do you have any doubt till now in the magnification part?
No.
Clear है सबको? Yes or no? कुछ तो बोलो.
Yeah, clear.
ठीक है?
Yes.
So देखो, no need to write this thing. This is already in the notes. Okay? The thing that I wanted to, अच्छा, देखो, magnification का formula होता है minus v by u. In the mirror case, it is minus v by u, and it is magnification is also the ratio of height of image to the height of object. Clear, everyone?
Yes.
चलो, that's great. ठीक है? So now let's do the numericals based on the, अच्छा, यहाँ पे मैं लिख देता हूँ sign convention. So this. So right now we are just going to discuss the theory with 1 or 2 examples. After completion of this chapter, we will be taking a dedicated numerical session for mirror formula, lens formula, power of a lens, and all the things combined. Clear? Yes or no? ठीक है?
Yes. Yeah.
Yes.
Just a moment, but actually my laptop is hanging a little bit. Okay. So now let's do the formula, sorry, question based on the mirror. Okay. So question is saying that this is a very basic question. Question is saying that, okay, now let's do it together. Question is saying, find the size, nature, position, and the position of the image formed in the object of size 1 centimeter. The size of 1 centimeter is what? Can anybody tell me what is 1 centimeter? Anyone? No one?
Size of the object, magnification.
No, it is not magnification, Harish. It is this height of the object. 1 centimeter means height of the object. The size of the object is 1 centimeter. One more thing, magnification does not have any unit. Magnification is a unitless quantity. Because V by U is basically nothing but centimeter by centimeter. It's nothing but a number, one. Whether the object is meter, centimeter, millimeter, anything. Because it is getting cancelled, and the unit getting cancelled, only number is left. So linear magnification is a unitless quantity. Clear? So now let's understand this thing one by one. First of all, our task is to write all the given information. Okay? So size of object is given. It means that height of object is given. That is 1 centimeter. Why it is positive 1 centimeter? Hello? Because object is placed upright, na? It is above the principal axis. If I'm sitting right now, if I'm taking the ground as principal axis, so I'm above the principal axis. Yes or no? My height of the upper body is above the principal axis. So that's why it is 1 centimeter positive. If it's lower, if it's basically downwards the principal axis, so it would be -1, right? At a distance of 15 centimeter from the concave mirror. So the object is placed at a distance of concave 15 centimeter from a concave mirror. Now tell me what is the object distance, everyone, in this case?
-15.
-15. Very good, Adish. So it is -15. Okay. Focal length of concave mirror is also given to you. That is, now tell me whether it's positive or negative. Focal length of concave mirror. We have discussed in the image formation part.
Positive?
Yes, Zainab, you said something?
Positive?
Okay, Zainab said positive. What about rest of you? Arish, Aayan, and Junaid? Positive or negative?
Never mind. Negative.
Okay.
Yeah, negative.
Negative. Arish?
Negative.
Okay, Aayan, negative. Okay, Junaid?
Negative.
Negative. Because concave mirror is like this. The rays form, basically the rays converge at this point. This is the pole and you are going in this direction. So obviously it's going to be negative. Okay? And I've told you that whenever you hear the word concave, whether it's lens or mirror, it's going to be negative. For convex, it is always positive. Okay? So now let's use the mirror formula, that is 1 by f. Take 1 by. Now substitute all the values. -1 by 10 is
Sir,
equals
I
to
got
1 by v.
30 centimeter.
Okay. Okay. Now let's verify it, Zainab. Okay. Because positive is here and negative of 15. So positive and negative will become negative. Yes or no? So now
Yes.
you can see this thing, everyone. On the one hand, basically this is a variable. It means that we have to find the value of this. So I will be shifting this on the left hand side. Yes or no? So that I can easily solve it. 1 by v is equals to positive 1 by 15 minus of 1 by 10. Okay. So I've told you that you have two options, whether like you can take the LCM as well as you can cross multiply. So I'm going to cross multiply because that is a simpler method. 10 into 1, 15 into -1, -15, and 15 into 10. So it is -5 by 15 into 10. This will be cancelled by 2 times. Negative of 1 by 30. So I got the value of 1 by v as -1 by क्या हुआ? 30. -1 by 30. 1 by v is coming out to be -1 by 30. But I need the value of v, not 1 by v. So I will be taking the inverse of it. So v will become -30 centimeter. Okay. Now we have got the value of the position of the image, that is negative 30 centimeter, right? So as you can see this thing, it is negative 30 centimeter. So negative word negative is there. So it means that the image is formed on the same side of the object. It means that it is going to be a real and inverted image, right everyone? Because it is forming in front of the mirror, not behind the mirror. So in all the cases which all the images formed in front of the mirror will be negative, right? So it is negative 30, and we have to find the height size of the image as well. So to find the size of the image, everyone, so I'm going to use the just a second, everyone. Let me don't know what has happened to this one drive. It is on. Okay. So 1 by 30. So to calculate the height of the object, that is height of the image, sorry, height of the object is already given. So my magnification is minus V by U. It is also equals to H dash by H. These two ratios are equal. So can I equate them? Minus V by U will be equals to H dash by H. Yes or no, everyone? Bolo? Can I do
Yeah.
this thing or not?
Yes.
Right?
Yeah.
So this is equals to H dash. Okay. So I'm going to substitute all the values. The negative is also already there. So negative of 30. Always substitute the sign. Okay. U is negative 15 is equals to height of the image we have to find.
Negative
Height
2.
of the object is 1. Okay. Because this negative will get cancelled. Positive 15 will be will cancel the negative 30 by negative 2 times. So this one will get multiplied to ultimately the H dash is coming out to be minus 2 centimeter. So as you can see this thing, everyone, the image is basically negative. The height of the image is negative. It means that it is inverted because the negative sign shows the image is real and inverted. So the nature of the image is and enlarged. The object was 1 centimeter, but the image is 2 centimeter. If you basically ignore the negative sign, the height of the image is greater than the object, so it is enlarged. Okay. Well, clear, everyone?
Yes.
Does anybody have any doubt so far? Please let me know.
No.
Chalo, okay. Now let's do one more question, and now we will move to the next topic because I'll be taking this topic like the numerical session dedicatedly. Just a second. Let's take a numerical based on the convex mirror. And what happened? Do you have any issue with your camera, bache?
Oh, I didn't see it's off.
Please, whenever you are in the class, please be please switch on your video, okay? Because it will due to that the decorum of the classroom is maintained. Okay. Just a second, bache. I got the question. I'm giving you 2 minutes. At least try this question. Okay, just try it. If you can solve it, that is well and good. If not, that is also good. No need to worry about that. Okay. Just I'm giving you 2 minutes to solve this. Please do let me know if you are able to solve it. Just a moment, everyone. I'm sharing my screen again. Any answer?
Will it be virtual, erect, and diminished?
Yeah, yes, Aayan, it's a convex mirror. So it's going to be virtual and erect. So that is correct. But I need the actual answer. That is in terms of centimeter. Please let me know in the chat, Aayan. Hello, Faizan. Assalamu alaikum. Faizan,
Yes,
how are you?
good.
Good. You are half an hour late, Bache. What happened?
There was a network issue.
The network. Chalo, theek. So I've discussed the mirror formula, yeah. Okay. So we have done the one question based on the mirror formulas. We are doing the second question. Please do try it.
I got the answer.
Yes, Arish, you got the answer?
Yes.
Chalo, theek hai. Let me know in the chat, Arish. Please let me know in the chat. ठीक है. ठीक है, Arish. Okay, Faizan. What is 3 centimeter, Faizan? Image size, object distance, image distance. What is it?
The size of the
Please,
image.
size of image. Okay, everyone. So let's do this question. Okay. An object of 5 centimeter is placed at a distance of 10 centimeter from a convex mirror. The 5 centimeter is height of the object. So that means the height of H is basically 5 centimeter. It will be positive because it is above the principal axis, right? Height is basically 5 centimeter. U is given to you as distance at a distance of 10 centimeter from a convex lens. So a convex mirror, basically every time whenever you write the image object distance, it always going to be negative irrespective of the type of mirror, whether it is convex, concave, the object distance will always be negative. Clear, everyone? Because it is basically placed on the left hand side. In this case, the curvature is given to you as 30 centimeter. So as you देखो बच्चों, for convex mirror convex mirror word is used, means that the focal length of the convex mirror will be positive because image is formed behind the mirror. So it is going to be 30 centimeter. And there is a relationship between the focal length and the radius of curvature, that is r by 2. So it is 30 by 2. So it is the focal length of the convex mirror that is given is 15 centimeter. Okay. Now we have height, object distance, and focal length. We have to find the position first. So implement the mirror formula, that is 1 by V plus Q 1 by U. So substitute the values 1 by 15. Same. By 15. Okay. 1 by V we have to find negative of 1 by 10. Okay. I'm going to shift the 1 by 10 on the left hand side, so it will become positive. 1 by V is equals to 1 by 15 plus 1 by 10 is equals to the 2. So, okay. So what we will do, we will cross multiply 10 plus 15 divided by 15 into 10. Okay. So it is 25 divided by 15 into 10. So all these are basically the multiple of the 5. So it will cancel by 5 times. This will cancel by 3 times. Okay. And this will cancel this by 2 times. So it is coming out to be 1 by 6. Okay. Positive 1 by 6. So 1 by V is basically coming out to be 1 by 6. So if I basically take the inverse of it, so it will be 6 centimeter. Clear, everyone?
Yes.
Okay. So it is going to be. Any doubt so far to anybody?
No.
No.
Sure.
Sure.
Okay. Sure. So this is V. Okay. Now we have to find the size of the image as well. So how to find the size of the image using the magnification formula, that is minus V by U is equals to H dash by H. So minus V by U will be equals to H dash by H because the ratios are equal. So minus V will so this V is positive. So minus of 6 by minus of 10 is equals to H dash we have to find divided by 5. So this negative will cancel this. Okay. I'm going to take I'm shifting this 5 on the left hand side. So it will become H dash will become 6 into 5 divided by 10. So this is coming out to be 5 to the 10 and 2 3s are 6. Okay. Or you can multiply it 6 5 to 30 and divided by 10 would be 3 centimeter. So as you know this thing, everyone, that the image is basically positive. The height of the image is positive. It means that the image is upright. So it's going to be a virtual and direct image. So the nature tell me whether it's diminish or enlarge of same size. Bolo bachcho?
Diminish.
Diminish. Yes, it is diminish because concave mirror always produce diminished images. Virtual. Direct. And clear, bachcho? Say yes or no at least.
Yes.
That's great. Okay. So that's how you implement it. I'm giving you last question to solve it. Then we will start the refraction. Okay. So just a second. This is an NCERT question. Please do it. I'm giving you 2 minutes to solve it. Please to solve it.
Is the answer minus 30?
Who said minus 30? Aayan?
Me. Not
Okay,
minus
okay.
30, plus 30.
Plus 30. Okay, ठीक है. We'll verify it. Just wait a second. Just give me a moment. Any answer from anybody? No one. चलो ठीक है.
Positive
Okay,
30.
okay.
Sir, I got
Okay,
minus 30.
Okay,
That-
Faizan. Junaid, any answer? What happened to Zainab?
No, I
Just a second. Ayan? Oh, sorry, Junaid. Any answer? No. चलो
minus
ठीक है.
30. The minus
Okay, minus
30.
30. ठीक है. अच्छा ठीक है देखो क्वेश्चन is saying a concave mirror produces 3 times magnified real image. Okay, so magnification is given to you in this question, that is m. So as it is a real image, so it would be -3, right everyone, because the real image means inverted image. So the magnification would be -3. An object is placed in front of it where the image is located. So object distance is given to you as -10. Okay, so the formula says my m is equals to minus of v by u. Okay, so -3, substitute the values -v divided by -10. This negative will cancel this thing and 10 will go there. So v will be equals to -30 centimeter. देखो, the
So why
image
did you
is
take
formed.
M as -3?
Yes, Arish, who said -3? Is somebody saying something?
Isn't it supposed to be +3?
How, Arish? Tell me, how is it positive? Supposed to positive? The
Because they
magnification.
enlarged.
देखो, enlarged doesn't mean that it's going to be positive. The number is saying 3. It means that it is 3 times the object. But it is saying real image, so negative sign will be there. Na, Arish, I've told you in the just a second. Negative magnification, so negative magnification signifies real and inverted image. Right? Clear, Arish, now?
Yes.
If
ठीक है?
V
So
is
that's
minus
why it
30, if V is minus 30, so the image is 30 centimeter in front of the mirror.
in front of the mirror, yes.
Uh,
Because it's concave mirror. If it's
Yeah.
real image, so the image formed will be in front of the mirror, not behind the mirror. ठीक है?
Yeah.
Check it. Now let's understand the new topic, that is the refraction, right? We will discuss the more numerical. Once we will complete the all theoretical part, we will discuss the numerical based on the mirror formula, lens formula, and power of lens in detail. Okay, so that we can take a dedicated class for it. Okay. Now tell me everyone, what do you mean by refraction?
Bending of
Anyone?
light after
Bend.
uh, bending of light, yeah. Light
Oh,
rays.
bending of light. Okay. What about Faizan, Junaid, and Arish? Yes, everyone. Any answer? What happened, everyone?
Bending of light.
Bending. Okay. Faizan, Junaid,
Bending of light. Bending of light.
bending. Okay, so let me tell you what is basically. So as you can see this thing on the screen, the question in the simple words, the change in direction of light rays when it passes from one medium to another medium obliquely. It means that it is basically striking basically the media obliquely with some angle. Obliquely means with some angle, right? It's called refraction of light. It is due to the change of medium. The refraction of light happens due to the change of medium. Okay. The refraction light takes place at the boundary of the two mediums. Suppose that this is air and this is water. So this is the point at which refraction will occur. It means that it is the boundary point of both the two medias. Yes or no, everyone? Is this clear?
Yes.
Aayan, Arish, Junaid, and Faizan. What happened, Arish? Are you writing something?
Yeah.
No.
Okay. Please do not write it. It's already there in the notes. You don't have to write it, right? Just be in the just look at the screen. Okay. So the image is sorry, the rays will strike the media obliquely and it will get refracted. It will bend it. Okay. So bending of light depends on the two things. First of all, which type of medium we are taking. The two medias that we are taking are rarer, denser, which one, and from which basically the light is going from which medium to another medium, right? It depends. Okay. So we have to understand in some cases the light ray will bend away from the normal, and in some cases the light ray will bend towards the normal, right? We'll discuss it in detail. Is this clear to all of you till now?
Yes.
Yes.
Sure, that's great. Okay. Okay, so first of all, the refraction. Okay, the refraction of light, the bending of light is happened due to the change in speed of light going from one medium to another medium. If the light ray is going from air to water, so obviously air is another medium, water is another medium. So there is a change in the medium, right? So
Yeah.
light rays will change the speed. The speed of light is different in air. Speed of light will be different in water, or it will be same.
Different.
Different, na? So that's why the bending of light will occur. Right, everyone? So the
Yeah.
refraction will occur due to the change in speed of light when the light rays goes from one medium to another medium. Okay? Aayan, Arish, Junaid, and Faizan. Clear?
Yes.
Sure,
Yes.
that's great. Okay. Now see this thing. So greater the change in speed of light. So suppose that light was traveling at 3 lakh kilometer per second. But there is a sudden change in the light, basically sudden change in the speed of light. Suppose that the light speed drops to suppose that only 50,000 kilometer per second. So there is a drastic change in basically the speed of light. There is a drastic change 3 lakh kilometer directly to 50,000 kilometer per second. So there is a very big change now. So more the amount of change in speed of light in the two medias, the greater will be the amount of refraction. Okay. So suppose that light is going from this medium to this medium. So if the difference basically is large, then the refraction will be also large. It means that bending of light will be more in that case, right? Small change in the speed of light, small will be the refraction. Is this clear to all of you?
Yes.
Right? Sure, that's great. Okay, now let's understand what is optically rarer medium and what is optically denser medium, because these two terms will be basically there when you will study the refraction. The whole refraction based on these two terms, rarer medium and denser medium. When rarer medium and denser medium. Okay. So first of all, rarer medium. A medium in which speed of light is more is known as optically rarer medium. It means that when the light rays goes from a rarer medium, the light speed of light would be more than any other medium. If it is rarer medium, it means that the density of this medium will be less. The example for the rarer medium will be air, because the density of air is very less now. The particles are very far from each other, right or no? Yes or no?
Yes.
Just
Yes.
okay. So the light, so the example, best example for the rarer medium is the air. Okay, now let's take the next thing, that is optically denser medium. So denser medium means in which the medium in which the light speed of light is less. It is known as optically denser medium. Clear?
Yes.
So density of the medium is high. Suppose that water, wood, water, glass, and glycerin, kerosene oil, all these things are basically denser than the air. Yes or no?
Yes.
Right? So examples for the denser medium would be this. So basically, we are taking the reference. If we are taking two medias, suppose that air and water, which one is denser?
Water.
Water will be denser. This one will be rarer. Suppose that two medias we are taking, water and glass. Do you know which one is denser?
Glass.
Glass. Obviously, because glass is a solid, so it will be more dense than the water. Arish, Junaid, Aayan, and Faizan. Yes or no?
Yes.
So it will be more
Yes.
dense than the water. So the quantity that will basically identify whether it is denser or rarer, we will discuss it in the next part of basically in the next topic. That is the refractive index. Clear, everyone? So this is how you will identify whether the object, whether the medium is rarer or denser. Okay? Chalo, that's great. Now let's understand. Okay. So now let's understand how the rays will basically, you can say, behave if the light rays are going from rarer to denser or denser to rarer. Okay. So first thing is basically suppose that this is incident ray, light ray is going at this point. So this is the refracted ray. This is the original path was this, but due to the change in speed of light, this is the refracted ray. Clear hai, bacho?
Yes.
Okay. So as you can see this thing, the light ray is basically the refracted ray. The angle of incidence is this, and the angle of refraction is this. So as you can see this thing, angle of incidence is greater than the angle of refraction. It means that the light ray has bended towards the normal. Bolo?
Yeah.
Yes.
Original path was this, but actually the light ray has bended towards the normal. This was the actual path, but light ray has bended towards the normal. There is a gap. Na angle itna shift hua hai. Yes or no?
Yes.
Right? So that's why when the light ray goes from rarer to denser medium, the light will bend towards the normal. Clear?
Yes.
Aayan, Faizan,
Yes.
Junaid, and Arish. Clear? When the light ray goes from rarer to denser, it will bend towards the normal. Okay? Now let's take the case for the denser to rarer medium. Just taking the vice versa of it. So this is the angle of incidence, everyone. Right? And
Yes.
the light ray should go like this without any bending of light, like this. Yes or no? Original path was this, but the light ray is basically gone away from the normal. This is the angle of refraction. This is the angle of refraction. The angle of refraction is greater than the original path, original angle, right? It is greater than the
Yeah.
angle of incidence as well. So whenever the light ray goes from denser to rarer, it is going to bend away from the normal. So two cases are there. First case is when the light ray goes from rarer to denser, so it will always bend towards the normal in the rarer to denser medium. And in the denser to rarer medium, light will always refract away from the normal. Please let me know, everyone, is this clear to all of you? Arish, Junaid, Faizan, and Aayan.
Yes.
Because
Yes.
if you have any single doubt now, just say it right there, because that's why I've taken this 2-hour class so that we can cover up the major portion based on the refraction, because this is almost the theoretical part. So that's why I'm taking each and everything in detail. So if you have any doubt, just say it right now, because that will be haunting in the next topic if you do not understand it, because refractive index is based on the refraction. If it's clear, please do let me know.
Yeah, it's clear.
Faizan, it seems like you are a little bit distracted in the class. Please be attentive here in the class. Okay. Yeah, that's okay. So these are the two cases based on the rarer and denser medium. Okay, clear everyone? So ekdam, no doubt.
Yes, sir, clear.
Chalo, theek hai. Now let's understand what are the effects of refraction that we see in our day-to-day life. So देखो, refraction is basically occurs in our day-to-day life. Suppose that an object is placed, if the object is placed in the water, suppose there is a heavy object placed in the water, basically, so that object will be appears to be raised. It will be like it is not at the depth, it is basically actually at a raise, basically higher position, right? If you basically drop a pen, if you drop a stone, what will happen? What will you observe? That stone will appears to raised. It is not right. Yes or no, everyone? It will be appears to be raised. Clear? Yes or no?
No,
Say yes
I
or
didn't understand.
no. अच्छा ठीक है. Suppose that देखो ये एक बॉक्स ले लेते हैं, ये पानी है सब, तो यहाँ पे आपका ये स्टोन है, ठीक है, आपने बट ड्यू टू रिफ्रैक्शन द स्टोन विल बी अपीयर्स टू बी लाइक दिस. देखो मैं इसका एग्जांपल दिखा देता हूँ, जस्ट एग्जांपल दिखा दो, पिक्चर है मेरे पास, जस्ट हाँ देख एग्जांपल देख. So object, you can see this thing that pencil is basically there in the glass. Oh, sorry, not sorry, in the glass, in the glass of water, right? So as you can see this thing, it should be like straight, but due to refraction, it is bended. It is looking, it appears to be raised. Yes or no?
Yes.
Right?
Yeah.
Yeah. One more example, let me tell you. One more example. You can see also see this. You can also see this thing that basically a boy is sitting at the rock and he's fishing right now. Okay. As you can see this, you can see this thing that this is the stick, but due to refraction, it appears to be raised. Yes or no? Dekho,
Yes.
right? So that's why the object appears to be raised due to refraction when it is basically submerged in the water. Okay?
Yes.
Sure. Okay, so let me a pencil. So I've given you the example of the pencil as well. So it appears to be partial. If the pencil is partially immersed in the water, so it appears to be basically bent at the water surface, right? This one, a pool of water appears to be less deep than it actually is. Suppose that there is a pool of water in your basically swimming pool. You will feel that the water, basically the pool is not that much deep. than the actual depth. It looks like it's very like the depth is very like 1 or 2 meter, but in actually it could be up to 10 meters, right? Due to the refraction, the pool appears to be less deep than the actual, right?
Yes.
Clear, Faizan, Junaid, Arish, and Ayan?
Yes.
Yes.
And one more thing is that in the human eye chapter, we will discuss the atmospheric refraction. So refraction is also basically occurs in the atmosphere, and due to that, the stars twinkle. This is the phenomena that we will basically discuss in the human eye chapter. So the star appears to twinkle in the sky. This is due to the atmospheric refraction. Clear?
Yes.
Please let me know, everyone. Is this clear to you so far or not? Any doubt till now, the effects of refraction? Arish, Junaid, Faizan, and Aya.
But no doubts.
Sure? Sure.
Yes.
ठीक है. Now let's discuss the next topic, that is the major topic in this case, and maybe in some time, maybe like in the exams, this image could come to draw. They will ask you to they will ask the question in such a manner that what is lateral displacement? Draw a ray diagram for the lateral displacement, or for a glass slab showing that the emergent ray and the incident ray are parallel to each other. So this will be the type of question that will be there in the exams. So first of all, now let's understand it. How to draw it. सबसे पहले देखो lateral displacement मैं यहाँ draw कर देता हूँ last में. डिस्कस कर लेते हैं क्योंकि drawing. So देखो. So this is a glass slab. ठीक है everyone. So this is a glass slab. So when the light ray is basically incident on the surface. So the point of incidence now normal will be drawn at the point of incidence. बोलो yes or no? ठीक है. As you can see this thing, this is the angle of incidence. So this is air. The light ray is coming from air. Okay. And this is glass. So light is going from denser to rarer or rarer to denser. Which one? बोलो बच्चों.
Rarer to denser.
Rarer to denser by Aayan. What about you, Arish and Junaid?
To rare, denser to rare.
Denser to rarer by Junaid. Arish, what do you say?
Wait, no, rare to denser.
Achha, rarer to denser. Arish? Okay, Junaid. Okay, got it. Bachi. Arish, are you there in the class? I think so. He has some network issue. So as you can see, this thing light ray is going from rarer to denser because glass is denser there than air. So the light ray should bend towards the normal. Yes or no? Like this, dekho. It will
Yes.
bend towards the normal. So as you can see, this thing there is no other basically medium in the basically inside the glass. So it will travel its original position like this. If it's bended, so it will go along this line path. Yes or no?
Yes.
Yeah. So as you can see this thing, but now this point is basically this is the again the point of incidence for this boundary. This is the point of incidence. Dekho. If I draw the normal, this will be act as a point of incidence. So in this case, can anybody tell me what will be the type of refraction, whether it's going from denser to rarer or rarer to denser at this point? This is at point A, it was rarer to denser. Now tell me for the point B.
Denser to rarer.
Denser to rarer. This is the angle of incidence. This is the angle of incidence. Okay. This is angle of refraction. So these two normals are parallel to each other. So this will be behaving as a transversal, everyone. Do you remember transversal line between the
Yes.
parallel lines? So this angle will be nothing but the alternate interior angle, everyone. Aayan, Faizan, Arish, Junaid. This angle, alternate interior angle. Transversal, alternate interior angle.
Yes.
Right? Like this. Alternate okay? Z
Yeah.
type thing. Right? So this is called the alternate interior angle. Okay. I'm really sorry, everyone. Actually, there was a sudden, you can say, outbreak of the light. Okay. Okay, Ayan, Faizan, and Arish. Okay. Is this clear? Visible is screen, maybe?
Yes.
Yes.
Sure. Okay. Okay. Too rare at this point. So the light ray will bend away from the normal like this. Clear? Hai?
Yes.
So as you can see this thing, there go. As you can see this thing, there is a displacement from the incident ray to the this ray is called emergent ray. Because this ray is getting emerged from the glass. That's why it is called emergent ray. Let me write here. Emergent ray, okay? And this would be incident ray. Please draw this diagram side by side. Actually, आपको थोड़ा सा वो you can say practice हो जाएगी जब आप साथ में draw करोगे, ठीक है? Because देखने में और अब जब आप खुद से draw करोगे तो if you have any doubt now, so you can ask me in the class as well, and the recording is also present, right?
Yes.
So incident, okay? So incident with this. So this one is done. So as you can see, okay. So this is emergent ray. So if I extend this line, bachcho. So if I extend this line, everyone, if I extend this line like this. So if I extend this line, so this is the actual incident ray. This should be the path without any refraction of this incident ray. But due to the refraction, the incident ray has been shifted by some distance, right? So
Yes.
this distance, if you take the perpendicular distance between these two rays, the incident ray and the emergent ray, that distance is called lateral displacement. That distance is called lateral displacement. The perpendicular distance between the emergent ray and the incident ray, is called the lateral displacement. Arish, are you there in the class, bache? Lateral displacement. Junaid, check it, bacho.
Okay.
Check it. So that's what. So this is the lateral displacement. So this is what lateral displacement is. Okay. So this is glass slab, right? So this will happen in the glass slab. Okay. Good out किसी को यहाँ तक?
Sir, can you explain lateral displacement again?
Lateral displacement basically lateral displacement means the distance, perpendicular distance between the emergent ray and the incident ray when the light ray passes through the glass slab is called lateral displacement. Okay.
Oh,
Yeah.
okay.
Clear?
Yeah.
So this is how the image is formed. Does anybody have any doubt so far? Please do let me know. Junaid, Arish, and Aayan. Arish, are you there? At least say yes or no. कुछ तो बोलो बच्चे. ठीक है? So this is the incident ray. This is the emergent. And the distance, perpendicular distance between is the lateral displacement. Clear, बच्चों?
Yes.
Sure. Okay. So now so this is the ray diagram involved in it. Okay. Ray diagram is drawn in the PDF as well. Okay. Emergent ray. And one more thing is that angle of incidence will be equal to angle of emergence. I just forgot to mention it. Angle of incidence is equals to angle of emergence. Clear?
Yes.
So if somebody says that, suppose this is 60 degrees. So what will be the angle with which the ray will emerge? So you will say that same 60 degree because angle of incidence is the angle of equals to angle of emergence. Clear, Aayan and Junaid and Arish?
Yes.
That's great. Now let's discuss it. So this is the definition: the perpendicular distance between the original path of the incident ray and the emergent ray coming out of the glass slab is called lateral displacement of the emergent ray of light. All clear?
Yes.
Sure. Achha. Okay, now this is a very interesting case. Suppose that light ray is falling normally to the glass slab or any material. Okay, so if the light ray is falling perpendicular, so there will be no refraction at all because angle of incidence is zero. Angle of incidence is zero, so there will be no refraction at all when the light ray passes or falling through the surface normally. Yeah. So if the incident ray falls normally to the surface of a glass slab, then there is no bending of ray, and it will go straight. It's not for it's not like restricted to glass slab. It's for any, you can say, material. If the light ray is falling perpendicular, so there will be no refraction at all in that case. Clear, bachcho?
Yes.
Do you have any doubt? Anybody?
No.
Sure?
Yes, sir.
Sure. Okay. And the incident. So now let's do the question based on that. Now tell me, जल्दी से इसके तीनों के example बता दो आप. Correct options.
Away from normal.
In the chat. And chat में बताता हूँ.
Okay.
तीनों के. चलो ठीक है, जल्दी से इसको डिस्कस कर लेते हैं. Question is saying when a light ray when a light ray traveling in glass enters into water obliquely, glass से water में जा रहा है. So glass is a denser medium and water is a rarer medium if we compare this thing. So it will refract towards the normal, no, because it is not rarer to denser. It is not refracted at all. Question already said obliquely. It means that there would be some refraction, right?
Yes.
It goes along the normal, not the case. It refracts away from the normal. Clear? So D option. Next is a ray of light falls at right angles to the boundary of parallel side glass block. The ray of light does not get refracted because it is falling perpendicularly. Perpendicular ray, so there will be no refraction. Clear, bachcho?
Yes.
Any doubt so far to anybody?
No.
Sure?
Yes.
Sure, that's great. Okay. Next is a ray of light passing from a medium X to medium Y. No refraction occurs if the ray of light hits the boundary of medium Y at an angle of. Now tell me the angle. Everyone, chat me in the chat. Okay, Junaid. Okay, yeah. Arish, what's the angle? Light ray passes from medium X to another medium Y. No refraction occurs. So the light ray hits the boundary. It's asking not angle of incidence. It is asking with what angle the light ray will hit the boundary. So that would be 90 degree. It is falling perpendicular, na? It's not asking an angle of incidence, Aayan. It is asking, Junaid, I think Junaid said the zero. Junaid. Sorry, Junaid said zero. So Junaid, it's saying with what angle the light should hit the boundary. The angle it should with which it hit the boundary is 90 degree, falling through the normal. Clear?
Okay. Yeah.
Okay. Sure. That's so okay. So as I've told you, when a light ray goes from rarer medium to denser medium, it bends towards the normal. When a light ray goes from denser medium to rarer medium, it bends away from away from the normal. Okay? Clear, bachcho?
Yes.
Sure. Now let's understand the next topic. That is the refraction, laws of refraction. So basically, as basically we have seen this thing that when the reflection, two laws were there. Similarly, refraction laws are also there. The first law is very similar to the second law of the reflection. The incident ray, the refracted ray, and the normal to the point of incidence all lie in the same plane. Clear?
Yes. Yeah.
Chicken? Any doubt to anybody?
No.
Chicken. Chicken. So as you can see, this thing, light ray is going from rarer to denser or denser to rarer. It is only in the plane. Okay. Next law is very important. So this law is called as Snell's law. Right. So as you can see, this thing, the ratio of sine, what does it say basically? The ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. It means that there is no change for a media if you take the sine of angle of incidence to the sine of angle of R, because angle of every angle of incidence has different angle of refraction. So that's why they are related to each other. So that's why the ratio is coming out to be constant. And this constant is called refractive index. Clear? Without anybody? Hello, Bacho?
Yes.
Any doubt so far? Because sine of angle, sine of incidence and sine of refraction is equals to constant, and that constant is called as refractive index. This is the term that will distinguish or that will determine whether the object will, whether the, you can say, object is denser or rarer, okay, with respect to the air. Clear?
Yeah.
Sure, that's great. Okay, so the value of the constant sin I by sin r for a given ray of light passing from air into a particular medium is called refractive index. So it means that when the light ray passing from air to any other medium, that is called refractive index. Okay, and this is denoted by either n or mu. Okay, this is denoted by either n or mu. So sin I by sin r is equals to mu or n. It is denoted by this. Clear, everyone? Does anybody have any doubt? Aayan and Arish, oh, sorry, Junaid and Arish. Clear बच्चों सबको आपको ये?
Yeah, clear.
चलो ठीक
Yes.
है. Okay. Now let's understand this. The refractive index of a medium is the ratio of two similar quantities. So it has no units. So refractive index is basically the ratio of two similar quantities. So see, quantities are same. So similar to the magnification was also unitless. So refractive index is also unitless. It is just a number. It tells you whether the ray will bend towards the normal or away from the normal with respect to air. Clear?
Yes, clear.
Okay. The refractive index gives an indication of the light bending ability of that medium. It tells you how much that medium, the light will be like how much the light will be bent towards the normal or away from the normal by that medium. Okay? It tells you how much the ability of that medium is. Clear? Clear, बच्चों? Arish,
Yes.
what did I say? Tell me. What did I say right now? Please tell me. Which line did I say?
You said the third line, the second line.
Second line. What does it mean? Explain it to me.
Um, I don't know how to explain it.
Please be attentive, Arish. If you do not focus on the screen or the words which I'm saying, so that class will be just go in vain without any, that will be not worth of you. So I'm requesting, please be in the class with an attentive mindset. Okay.
Okay.
So the refractive index gives an indication of the light bending ability. It tells you how much the light will bend by that medium. Okay. Clear?
Yeah. Yes.
So yeah, so now it's time to refractive index can also be written as the sine of angle of incidence and sine of angle of refraction. But there are two more ways to write the refractive index. The first one is the basically the speed of light. The second is the refractive index itself. Okay, now it's very important to discuss it. Now let's discuss it. So refractive index. Okay, so basically refractive index basically can be taken as the reference. The refractive index will be calculated with respect to a medium. Suppose that. So right now we have two types of refractive index, everyone. First one is relative, sorry, the absolute. Second one is relative. So absolute, in the absolute, one medium will always be air. Whatever the refractive index I'm calculating of a medium will be with respect to air. Okay? The relative, in the relative to all the two, both the two mediums will be different except air. That in the relative refractive index, air will not be involved. Clear? Clear? In absolute, air will be one of the medium. In relative, air will not be the medium. It can be glass, water, glass, diamond, water, diamond. It can be anything, but air will not be there in the relative refractive index. If one of the medium is air, then it would be definitely the absolute refractive index. Clear?
Yes. Yeah.
Yes.
Okay? This topic is very important, everyone. Please be attentive in the class. Okay? So now let's understand how to calculate the refractive index of one medium with respect to another medium. The refractive index of medium 2 with respect to medium 1 is equal to the ratio of speed of light in medium 1 to the ratio of speed of light in medium 2. If I'm saying medium 2 with respect to 1, it means that I'm taking the reference medium as medium 1. It means that refractive index of 2 with respect to 1. This is how it is written. Refractive index of medium 2 with respect to 1. 1 means superscript. The reference will be in the superscript. The medium for which I'm calculating will be in the subscript. Okay, it is the ratio of V1 by V2. V1 is basically the speed of light in medium 1 and speed of light in medium 2. Is this clear to all of you? Please let me know once. Arish and Junaid, is this clear?
Yes.
जुनैद क्लियर बच्चे आपको? आरिश आपको श्योर हो आप? क्लियर है?
Yes.
Next is, if you just take the vice versa of it, the refractive index of medium 1 with respect to medium 2. So in the subscript, medium 1 will come, and in the superscript, medium 2 will come. So in the velocity part, in the speed part, so V2 by V1 will be the case when the refractive index of medium 1 is found with respect to medium 2. Is this clear to all of you? Please let me know once.
Yes.
ठीक है? So,
Yes.
अच्छा देखो, can I write this thing as, देखो, so 1 by V1 by V2, देखो, this is a double division, so this will go in the numerator. So can I take the V2 in the denominator? बोलो Arish and Junaid, can I take it or not?
Yes.
Yes. So देखो, this is nothing but what? This na? Refractive index of medium 2 with respect to 1,
Yes.
right? So this will be, so that's how the relationship is obtained, that the refractive index of medium 2 with respect to 1 is just the reciprocal of the refractive index of medium 1 with respect to 2. Is this clear to all of you? Aayan
Yes.
and Arish, Junaid.
Yes.
Sure?
Yes.
Sure, that's great. So this is the relationship, basic relationship between the refractive index of medium 2 and medium 1. Is this clear to all of you, Junaid and Arish? Please be serious, because this topic is a little bit, you can say, tricky. You have to understand whether, like, which one should be with respect to medium 1 and which one should be another. Okay? Please let me know if it's clear, completely clear, if you are confident in it.
Yes.
Okay? Now let's understand, as I've told you that refractive index, two types of refractive index are there. So first one is absolute refractive index. When a light ray is going from vacuum to another medium, vacuum means air. Air should be involved. If we are saying one of the medium is air, then it will be absolute refractive index at any cost of that medium, right? So refractive index of medium from when the light ray goes from vacuum to another medium, then the value of refractive index is called the absolute refractive index. Clear? Bolo Aayan, Arish and Junaid. Is this clear? Yes or no? At least say yes or no. Kuch to bolo
Yes.
bachcho.
Yeah. Yes.
Okay, so this is how you will calculate the refractive index, absolute refractive index of the medium. That is N is equals to C by V. Clear?
Yes.
Junaid and Arish, clear?
Yeah.
That's
Yeah.
it. Next is relative refractive index. When a light ray is going from one medium to another medium, both the medium, like any of the medium, should not be air. Both the two mediums should be different from air. No air medium should be involved in that, right? So when the light ray is going from one medium to another medium, then the value of refractive index is called relative refractive index, right? So this is the relative refractive index, as I've told you that. देखो यहाँ पे हमने velocity वाला part कर लिया. Refractive index of medium 2 with respect to 1 is V1 by V2, and here यहाँ पे आपका refractive index वाला part है. Refractive index of 2 with respect to 1 will be the ratio of refractive index 2 with respect to 1. देखो velocity और refractive index reciprocal में use होंगे, इस चीज का ध्यान रखना. Velocity में यहाँ पे V1 by V2 होता है ना. देखो अगर हम medium 1 को reference medium लेते हैं, but refractive index में medium 1 ही reference medium है, तो वो denominator में रहेगा, but velocity में वो numerator बन जाएगा. Clear है? Ayan and Arish, clear है? Arish and Junaid, ये clear हुआ या नहीं आप? Relative
Can you
refractive index.
say it again? Can you explain
Yes.
this
check
part?
check 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 देखो देखो यहाँ पे हमने देखो रिफ्रैक्ट देखो मैं as I've told you that two relationships are there for the refractive index, relative refractive index. ठीक है? First one is
Yeah.
related to the speed of light. ठीक है? Clear?
Okay.
Second one is related to the refractive index. देखो यहाँ पे हम लोग दो refractive index ले रहे हैं तो यहाँ पे रेशियो की बात आ रही है. तो इसमें क्या था देखो ये तो स्पीड वाला था तो इसमें जो when the reference medium is 1 सो आपका जो न्यूमरेटर में है वो स्पीड ऑफ मीडियम 1 ही आएगी बिकॉज देखो ये ऑलवेज ग्रेटर होगा सो दैट्स व्हाई इट विल बी ग्रेटर देन 1. क्लियर है आया जुनैद एंड आरिश?
Yes.
ठीक है.
Yes.
अब यहाँ पे मीडियम 2 को हमने रेफरेंस मीडियम लिया है सो वेलोसिटी ऑफ मीडियम 2 इज टेकन इन द न्यूमरेटर. सो इन इफ यू टॉक अबाउट वेलोसिटी सो जो भी हम रेफरेंस मीडियम लेते हैं उसकी वेलोसिटी विल बी इन न्यूमरेटर. दैट वेलोसिटी विल बी इन न्यूमरेटर. क्लियर? जुनैद आरिश क्लियर है ये वाली बात?
Yes.
ठीक है. दूसरी बात अब यहाँ पे आ जाते हैं हम लोग यहाँ पे हम लोग ले रहे हैं रिफ्रैक्टिव इंडेक्स का रेशियो. यहाँ पे हमने लिया रिफ्रैक्टिव इंडेक्स का रेशियो विद रिस्पेक्ट टू 1 ले रहे हैं सो उसका जो रिफ्रैक्टिव इंडेक्स होगा मीडियम 1 का वो डिनोमिनेटर में आएगा. वो अब वेलोसिटी से रिवर्ट हो जाता है. ये वेलोसिटी में क्या था मीडियम 1 ऊपर आ रहा था बट यहाँ पे क्या होता है क्योंकि हम लोग रेशियो ले रहे हैं तो विद रिस्पेक्ट टू 1 मींस सो इन द डिनोमिनेटर n1 विल बी इन द डिनोमिनेटर and n2 विल बी इन द डिनोमिनेटर. क्लियर हुआ आपको ये?
Yes.
जुनैद एंड आरिश क्लियर?
Yes, sir.
बोलो जुनैद क्लियर हुआ बच्चे आपको ये?
Yeah. Yeah.
श्योर?
Wait, how do you find out which one to use? How do you find out which one to use?
Didn't get your word, Junaid. Please tell me again.
How do we find out which one to use?
देखो, we will discuss when we will do the numerical. I'm just taking the numerical so that you can understand it properly. देखो,
Okay.
ठीक है? देखो, ये चीज क्योंकि ये ऐसे आपको verbally नहीं समझ में आएगी, but when we will do in the numerical, ना, that will be it. देखो, question is saying light enters from air into glass having refractive index of 1.5. So this is the glass of having refractive index of 1.5. अच्छा देखो, air का जो refractive index होता है that is 1. Refractive index of air is 1. ठीक है? So that's why in the absolute refractive index, air is taken as the reference medium. ठीक है? So light enters from air into in the glass having refractive index of 1.5. So n is 1.5 I have taken. Speed of light is given as 3 lakh kilometer per second or 3 into 10 to the power 8 meter per second. Clear? So देखो, as I have told you, air is involved as the medium, so it will be called as absolute refractive index. Yes or no? One of the medium is air, na? Light is going from air to another medium.
Yeah.
Hello, clear है?
Yes.
So देखो, ठीक है? Now we have to find the speed of light in glass. Air की तो हमें पता थी ये रही, हमें अब find करनी speed of light in glass. ठीक है? So the formula for the absolute refractive index is n is equals to c by v. देखो यहाँ पे मैंने आपको बताया n is equals to c by v. We need to find the value of v. V will be equals to c by n. Yes or no, everyone? So 3 into 10 to the power 8. 3 into 10 to the power 8 divided by 1.5 meter per second, because speed is in meter per second given. So it would be the 1.5 and 3. It will cancel twice a time. So the speed of light is 2 into 10 to the power 8 meter per second. So the speed of light has decreased in the class. 3 into 10 to the power 8 said 2 into 10 to the power 8. Yes or no?
Yes.
Clear? ठीक है? Any doubt to anybody till now? Harish and
No.
Junaid? ठीक है? Now let's take the next question. ठीक है? देखो क्वेश्चन क्या कह रहा है? Question is saying that the light, what is the speed of light in a medium of refractive index 6 by 5 if the speed in air is 3 lakh kilometer per second. 3 lakh kilometer per second is given, and we have to find the speed of medium. Similar type of question. Let's solve it. N is equals to C by V. वैल्यू निकालनी है V की. क्या हो रहा है? So value निकालनी V की, तो V would be C by V. Sorry, C by N. तो C की वैल्यू कितनी है आपकी? 3 लाख किलोमीटर पर सेकेंड. 3 लाख हो गया, 30. हाँ, 3 लाख. ठीक है, डिवाइडेड बाय 6 by 5. किलोमीटर per second, because speed is given in kilometer per second. So देखो, this is a double division. So what will happen? This 5 will go in the numerator, because this is a double division. No? This 5 will go in the numerator. So this will be 3. What is happening? Just a moment, everyone. Actually, I have to switch my AirPods. So it would be 3 lakh into 5 divided by 6. So this would be 6 5s are 30. So how many zeros are left? देखो, 5 5s are 25 and 4 zeros. 25 and 4 zeros. Kilometer per second. So this will be the speed of light in that medium. Is this clear to all of you? Please let me know once.
Yes.
Aayan and Junaid and Arish. Okay?
Yes.
That's how you will. Okay, so a substance having higher refractive index is optically denser. So if the substance is having higher refractive index, it means that it is optically denser medium. Okay, and if the another substance is basically having lower refractive index than another, so it's called as optically rarer medium in comparison to the another medium. Right, everyone? Arish and Junaid, bolo, clear?
Yes.
Okay. Next thing is that greater the refractive index, more it will change the direction of beam of light. So if the refractive index is high enough, so it will change the beam of light in a maximum manner, right? More will be the refraction happen at the surface. Clear, everyone? Bolo, clear है?
Yes.
Sure. Junaid, is this clear to you?
Can you explain it again? I didn't understand clearly.
I'm saying the greater the value of refractive index of a substance, it will refract the light more. Simple words. It will refract the light more. Value of refractive index determines how much the light will refract. More the refractive index, more will be the refraction. Lesser the refractive index, lesser will be the refraction. Simple. Clear?
Yeah, yeah.
Okay. Now let's understand the relative refractive index. Suppose that light is going from medium 1 to medium 2. Light is going from medium 1 to medium 2. So how to calculate the refractive index of medium 1 with respect to medium 2? Sorry, refractive index of medium 2 with respect to 1. Okay? So that would be V1 by V2 in terms of velocity. V1 by V2. Refractive index of medium 2 with respect to 1. So यहाँ पे 1 जो है subscript in the velocity, that would be 1. V1. And in the numerator, it would be V2. Clear, Junaid and Arish?
Yes.
Okay. And for the light ray going from medium to medium 1. So यहाँ पे revert हो जाएगा. Medium 2 will be in the subscript. So velocity of the medium 2 will be taken as the numerator. Is this clear, बच्चों?
Yes.
Yes. Yes.
ठीक है. और यहीं पे ये चीज और भी लिख सकते हो आप. रिफ्रैक्टिव इंडेक्स ऑफ मीडियम, देखो मीडियम refractive index of medium 1 with respect to medium 2. So in terms of refractive index, it would be n1 by N2। अब क्लियर हुआ जो ऊपर मैं समझाना चाह रहा था, दैट्स व्हाट दिस इज द सेम। क्लियर। एंड यहाँ पे देखो रिफ्रैक्टिव इंडेक्स ऑफ मीडियम 2 विद रिस्पेक्ट टू मीडियम 1 लेना है, तो N2 बाय N1। अब देखो समझ में आया आपको बच्चों? आरिश एंड जुनैद, क्लियर हुआ ये? इज दिस क्लियर नाउ?
Yes.
Yeah. Yes.
Sure. Okay, now let's discuss the question. अच्छा ये वाला क्वेश्चन रहने दो, क्योंकि ये क्वेश्चन ऑलरेडी रिफ्रैक्टिव इंडेक्स ऑफ एयर, ये एब्सोल्यूट रिफ्रैक्टिव इंडेक्स का है। नेक्स्ट वाला क्वेश्चन करते हैं। चलो यहाँ देखिए क्वेश्चन। दिस क्वेश्चन इज सेइंग speed of light in vacuum and different glasses are given to you, ठीक है? Calculate the absolute refractive index of flint glass and crown glass। देखो अगर refractive index of flint glass निकालना है तो air will be involved, right? So speed of light is 3 into 10 to the power 10 to the power 8 meter per second. Velocity of flint glass, देखो velocity of flint glass is given 1.86 into 10 to the power 8। Clear है? So this 10 to the power 8 will get cancelled। यहाँ पे आपका आ गया 3 by 1.86, 3 by 1.86। So it is coming out to be 1.61। Is this clear? Junaid and Arish?
Yes.
Yes.
ठीक है? Now let's take the crown glass। Crown glass में absolute refractive index find out करना है। Speed of light will be same 3 into 10 to the power 8 divided by crown glass की speed है 1.9 into 10 to the power 8। This will cancel this, so 3 by 1.97, so it would be 1.52। Now tell me which one will refract the light more, flint or crown?
Flint.
Yes, flint will refract the light more because the refractive index is greater of the flint glass। Clear it?
Yes.
Is it out? Clear everyone?
Yes.
देखो अब now we have to find the relative refractive index when the light is going from crown glass to flint glass। अब देखो हमारे पास क्या है, दोनों चीजें हैं, either we take the velocities or the refractive index। देखो हमारे पास refractive index का भी रिलेशनशिप है और हमारे पास refractive index उसका velocity का भी रेशियो है, right? Now what we will do is that you can either take the refract, देखो अब यहाँ पे हमारे पास speed of light का दे देते हैं। देखो light is going from which medium? Light is going from crown glass to flint, right?
Yes.
So question is saying कि आपको जो reference medium लेना है वो crown glass लेना है, क्योंकि light is going from crown glass। Clear है?
Yes.
Junaid, clear?
Yeah.
So it means that speed of light in crown glass divided by speed of light in flint glass, that is 1.97 into 10 to the power 8 divided by 1.86 into 10 to the power 8. So this 10 to the power 8 will get cancelled. Let me divide it 1.97 divided by 1.86. So it is coming out to be 1.05, right? देखो एक और एग्जाम, देखो इसका एक और मेथड है, let's explore that as well। Question is saying we have to find the flint glass with respect to crown glass। So that is flint glass with respect to crown glass। So the refractive index of flint glass divided by refractive index of crown glass. So what is the flint glass refractive index? That is 1.61 divided by 1.52. So if you divide it now, so that would be same divided by 1.52. Same 1.05. Clear? So these are the two steps that you can easily solve this question. Now, is this clear, Junaid?
Yes. Yeah.
Any doubt so far?
No. No
Sure?
doubts.
चलो ठीक है जरा ये क्वेश्चंस करो आप ये दोनों क्वेश्चन करो मुझे बताओ इसका आंसर then what's the answer
Uh, C. C.
see okay now let's understand this question is saying the refractive index of four substance is p q r and s okay so we have to find the speed of light is maximum in which substance speed of light is maximum in the substance in which the refractive index is less because less refractive index means lesser will be the bending of light it means that more will be the just a second. Yes, Junaid, sorry for the interruption. So as you can see, the lesser will be the refractive index, so higher will be the speed. Okay. So as you can see this thing, R is the substance in which the refractive index, not R, it is Q. It is Q. So Junaid, it is Q. No, R. Just a second. 1.31 is less now, 1.36. So it is this one. 1.31 is less than the less like is basically the smaller magnitude among all. So S is the correct option. Okay. My speed of light will be maximum in the S substance. Clear, Junaid?
Yeah. Clear.
Yeah. Next is the refractive index of four materials are given to you A, B, C, D. When the light ray pass from air into these material, they refract the maximum in. Maximum refract karna, it means that it is saying it will bend towards the normal. So that it means that higher the refractive index, higher will be the refraction. Right? Clear,
Yes.
Junaid?
Yeah.
So A, B, C, D, 1.33, 1.43, 1.71, and 1.52. As you can see, this among all, 1.71 is the maximum. So material C will be the correct option, which will refract the light most. Clear हुआ? Junaid,
Yeah.
आपको?
Yeah.
Any doubt?
No. No doubts.
ठीक है? चलो, that's great. अच्छा, Junaid, I'm giving you this, basically, I'm giving you 2 minutes to solve this question. Please find the correct answer and let me know.
Yeah.
Junaid, what's your answer? Okay, Junaid. So let's solve it together. कोई बात नहीं.
Okay.
कोई नहीं. Question देखो. Question is saying that the refractive index of glass with respect to air is 3/2. It is the absolute refractive index of glass because air with respect to air आ रहा है ना Junaid देखो. So it is absolute because air is involved. So it is refractive index of glass with respect to A is 3/2. And refractive index of water with respect to A is 4/3. Question is saying that refractive index of glass with respect to water. So question is saying refractive index of glass with respect to water. It means that it is saying Ng by Nw. Right? So अब देखो glass की जो refractive index है that is 3/2. Divided by 4/3. Okay, so this is a double division. So this will go in the denominator and this will go in the numerator. Yes or no, Junaid?
Yes, yeah.
Okay, so this will be 3 into 3 divided by 4 into 2. So this is coming out to be 9/8. So it is coming out to be 1.125. Okay, so D is the correct option. Please let me know, Junaid, is this clear to you or not? Do you have any doubts so far?
Yeah, it's clear now.
It's clear. So do you know how to use that? That's what I'm saying, because in the verbal, you can say explanation, you won't be able to understand which one is reference medium, which one is actual medium. So that's why numericals will help you in that, right?
Yes, yeah.
Okay. So that's why I've taken the numerical. Is this clear?
Yeah, this is clear. Yes.
Okay, so basically, that's I just wanted to cover the theoretical part as early as possible so that we can easily easily focus on the numerical portion, right? So once the theoretical portion will be covered, as only one major topic is left for the theoretical portion, but that is image formation of the lenses. So image formation of the lenses is the next topic that we will cover. And in the next class, inshallah, we will be completing the image formation, and only two topics will be left, that is lens formula and power of a lens. So in the coming two classes, all the theory portion related to this chapter will be done. Clear?
Yes, yes.
Okay. So in the next class, I will be covering the image formation and I will try to cover up the lens formula as well. So is it clear, Junaid? Now you can easily solve it, yes or no?
Yeah.
I will be
yes.
sharing some assignment question as well. Achha, one more thing, Junaid.